Okay students, let us look into a sum based on Bayes theorem. Suppose there is a factory which makes electric bulbs on machine A, B and C, where machine A manufactures 50% of the bulb, machine B manufactures 25% of the bulb and machine C manufactures the remaining 25% of the bulb. Out of the manufacturing that is done on the three machines, it is known that 4% of the bulbs produced on A and B are defective, whereas 5% of the bulb produced on C are defective. My question says if one bulb is selected at random, find the probability the bulb is defective. To get a defective bulb, your step number one is to select the machine and then get a defective from the machine. So we define event E1, E2, E3 to get the bulb from machine A, B and C. So probability of getting a bulb from machine 1 is 50%, bulb from machine 2 is 25% and bulb from machine 3 is the other 25%. Now, your defective from machine 1 is 4%, from machine 2 is 4%, and from machine 3 is 5%. If I put this data in a tabular form over here, my first question was, what is the probability of getting a defective bulb? Means you will select machine 1 and get a defective from machine 1, means I multiply these numbers, so I have 200 upon 10,000. Or I select machine 2 and get a defective from machine 2, means I multiply this, so this is 100 upon 10,000. And similarly, select machine 3 and get a defective over here is 125 upon 10,000. So chances of getting a defective bulb is adding these three numbers, which comes to 425 upon 10,000. So probability of getting a defective bulb is 425 by 10,000. Now, my second part of the question says you already got a defective bulb. What is the chance it came from machine 2? Means you already got a defective bulb. What is the chance it came from machine 2? That is probability E2 intersection D upon probability D, which over here is 100 out of 425, which makes it 25, 4 by 17. And hence my probability of getting a defective from machine 2 is 4 by 17.